Good evening everyone. Welcome to my class. In this class, let us discuss few important MCQ question based on the topic superposition of waves. In the last class, I explained the theory part of superposition of waves. In this class, the continuous part of that same concept superposition of waves. Today, I am going to solve few important questions. Okay, first question. The phenomenon of echo is an example of okay, now it is in live. Okay, first question. The phenomenon of echo is an example of first option reflection, second one is refraction, third one is transmission, fourth one is none of these, fifth one is not attempted. You know already the phenomenon of echo. Echo occurs because of the phenomenon of reflection. Very easy question. Why the echo it will happen? Reflection of sound, it will cause echo. Very easy question. The phenomenon of echo is an example of reflection. Reflection of sound, it will take place. Therefore, the correct option is reflection. Next one. If the incident wave and the reflected wave are completely out of phase, then the reflected surface is, first one, an open end of an organ pipe, second one, a non-rigid boundary, third one, a rigid boundary, fourth option, none of this. Understand the question. If the incident wave and the reflected wave are completely out of phase, if both completely out of phase, then the reflected surface is, what is the reflected surface? The correct answer is the reflected surface is a rigid boundary. Only you have to remember, this is the very important question. Only in the case of a rigid boundary means the boundary is fixed. Consider this is the wave, this is the boundary, consider this point is fixed, rigid, otherwise the fixed point. I explained everything in the theory of superposition of waves. Those who are not watched that video, please first watch the video superposition of waves theory part. Then easily you can solve MCQ question because these questions based on the topic. Okay. If the incident wave, reflected wave are completely out of phase, both also completely out of phase, then the reflecting surface it will be a rigid boundary. That one you have to remember. Okay. Once again I will revise what is mean by reflection, how it will happen in a rigid boundary and also non-rigid boundary. Everything I explained in detail, but quick recap. Okay. Reflection by a rigid boundary. If a pulse is like this one we will call it as a pulse, each one. Okay. If a pulse traveling along a stretched string, consider this is the stretched string. Pulse means when you disturb this string only, it will form a wave. Okay. If a pulse traveling along a stretched string is reflected by the rigid boundary, assuming there is no absorption of energy. See, when the reflection of sound takes place, whether it is a rigid or non-rigid boundary, some of the sound waves maybe it may get observed, some may it will get reflected, some maybe it will get even refracted also. But here in the case of a rigid boundary means this point is fixed, the string, otherwise when the pulse, when it will form, this fixed point it will not move up and down, it will be fixed. Assuming there is no absorption of energy by the boundary, the reflected wave has the same frequency. When there is no absorption of energy, when there is no absorption of sound energy, then the reflecting wave have the same frequency and amplitude as the incident pulse. Consider this is the one more diagram I will write here. Consider the incident and also reflected pulse. Okay, consider here, this is the incident pulse, this is the rigid boundary. Once it will hit the rigid boundary, again that pulse, it will be come back in this direction, correct? No, like this is the fixed point, like this the pulse it will come back. Okay, then here both the incident frequency, both the incident wave and also reflected wave you can consider, otherwise incident sound wave, reflected sound wave, both have the same frequency and amplitude. The incident pulse, it suffers a phase change of pi or 180 degree on reflection. Here what is the phase difference in this case? 180 degree, because it is traveling on a straight, correct? No, this is the incident pulse, this is the this one is the reflected pulse. I will show with the direction. This is the incident pulse, then this is the reflected pulse. Then here this phenomenon is applicable only for a rigid boundary. That one you have to remember. In the case of a rigid boundary, the incident pulse and also reflected pulse both have the same frequency, same amplitude, and also the phase difference between the phase change of incident pulse and reflected pulse, it will be 180 degree, because both are traveling in a straight line almost on reflection. This is because the boundary is rigid, the disturbance must have zero displacement all the times at the boundary. Yes, this point is very important. In the case of a rigid boundary, the displacement it will be zero. See here, consider this is the fixed point, this is the fixed point, there is no displacement of the wave. Once the pulse it will travel in this direction, in the opposite direction the reflected pulse it will travel, but here there is no displacement of the pulse, otherwise there is no displacement of the fixed point. Therefore in the case of a rigid boundary, zero displacement, that one you have to remember. But by the principle of superposition, this is possible only if the reflected and incident wave differ a phase difference of pi, so that resultant displacement it will be zero. What is the condition for a resultant displacement must be zero? The boundary it will be rigid, then the incident wave and also reflected wave phase difference is pi. All these cases it will be valid only in the case of a rigid boundary. Then what you have to remember in the case of a rigid boundary, the incident pulse and also reflected pulse both have the phase difference of pi. Displacement it will be zero, and also both the incident and reflected wave have the same frequency and also same amplitude. These are the few important points you have to remember. Here they ask the one question, so many number of questions they may ask, MCQ questions, easy. Next one, reflection by a non-rigid boundary. Up to here we studied in detail about reflection when it is a rigid boundary. Let us discuss what will happen if the reflection it will happen for a by a non-rigid boundary. If the boundary point is not rigid, see, consider this is the boundary, this is the pulse, then here this is the point, this is not fixed, okay, this it will be free, then it can move even up also, this point it can move even down also. This one we will call it as a non-rigid. If the boundary point is not rigid but completely free to move, yes, it can easily move up and down, easily move, such as in case of a string tied to a freely moving ring on a rod. This is the string, this is the ring, this is the string, this is the ring, then this is the rod. This ring is inserted inside the rod, then easily this ring it can move up and down. The net maximum displacement and the boundary is twice the amplitude of each pulse. This point is very important. In the case of a non-rigid boundary, the maximum displacement it will be equal to twice the amplitude. Remember, this point is very important. Okay, the net maximum displacement at the boundary is then twice the amplitude of each pulse. An example of a non-rigid boundary is open end of an organ pipe. when one end of the pipe is open. Organ pipe consider like this. One end is closed, another end it will be like open. Organ pipe. Understood? Which are the important points you have to remember? In the case of a non-rigid boundary, maximum displacement, it will be equal to twice the amplitude of each pulse. This is the one of the most important condition, reflection by a non-rigid boundary. And here this point is not fixed, it can move up and down. Therefore, you can observe a displacement in the case of a non-rigid boundary. Revise. Why I am explaining, I am stressing means you have to understand the concept. If a pulse traveling along a stretched string is reflected by the rigid boundary, assuming there is no absorption of energy by the boundary, the reflected wave has the same shape as the incident pulse, but it suffers a phase change of pi 180 degree on reflection. Hence, option 3 is the correct answer. Now, you can read one more time what is the question. If the incident wave, reflected wave are completely out of phase, then the reflected surface is a rigid boundary. When you will find a phase difference, definitely the boundary it will be a rigid boundary. Today I saw the notification, maybe they will call even primary and also high school teachers also. They will recruit soon. Within notification it will come within 2 or 3 weeks the notification, 2 or 3 months, sorry, the notification it will come. That's why those who are watching my videos better try to consider as a seriously, then try to read each and every day. Don't waste your time. Okay, once the notification come, maybe you will not get the time to read. That's why read. Next important one more topic, interference. We are having two types of interference. One is constructive interference, another one is destructive interference. When two waves superimpose, then the resulting amplitude of the wave at that point is the vector sum of amplitude of each individual waves. Interference, yes, when two waves, when they will get overlap, when they will get superimposed, that one we will consider as a interference. Here the resultant wave amplitude it will be equal to vector sum of the amplitude of each individual wave. That one you have to remember. This phenomenon we will call it as a interference of wave. There are two types of interference. One is constructive interference, another one is destructive interference. Let us discuss what is meant by constructive interference, another one is destructive interference. When two waves superimpose with each other in the same phase, when phase is same, the amplitude of the resultant is equal to the sum of the amplitude of the individual waves, resulting in the maximum intensity of light. This is known as constructive interference. You have to remember what is meant by constructive interference means two waves they will get overlap with the same phase, overlap with each other with the same phase. In the same side you can consider, same phase you can consider. In that case the resultant interference, otherwise the resultant amplitude of the resultant wave it will be equal to vector sum of the individual amplitude of the individual wave. Okay, then you will get the maximum intensity of light, because both the waves also they will be vibrating in the same phase. Then destructive interference, if two waves superimpose with each other in the opposite direction, different phase, okay, the amplitude of the resultant wave is equal to the difference in the amplitude of the individual wave. Here the amplitude it will be sum of, okay, here the difference. Here you will get the minimum intensity of light in the case of a destructive. In the case of a constructive, you will get maximum intensity of light. This is known as a destructive interference. Both also very easy, simple, okay. Difference you have to remember. In the case of a constructive interference, both waves they will get superimposed in the same phase. Then the resultant wave amplitude it will be sum of the individual wave. Then here you will get maximum intensity of light. Okay, Then in the case of destructive, two waves superimposed with each other in the opposite phase, then the resultant amplitude of a wave, it will be equal to difference in the amplitude of the individual wave. Then the intensity of the wave, it will be minimum here. That one we will call it as a destructive interference. Remember, okay. Let us move to the next question. A boundary is formed by two elastic media P and Q if a wave is moving in medium P and incident on the boundary formed by P and Q, then which of the following phenomenon will occur? Whether it will follow reflection, second option refraction, third option both reflection and refraction, fourth one none of these. Understand the question? A boundary is formed by two elastic media P and Q if a wave is moving in medium P incident on the boundary formed by P and Q, then which of the following phenomenon will occur? Both reflection and refraction it will occur. Even absorption of sound also it will happen, but here you don't have any option. But when you are considering two boundary, normally even reflection also it will happen, even refraction also. Okay. A boundary is formed by two elastic medium. They are given PQ. If a wave is moving in medium P and incident on the boundary by P and Q, then which of the following phenomenon will occur? You are having two boundary P and Q. Normally when sound waves enter between the two boundary, both reflection and also refraction it will happen. That one you have to remember. If a wave is generated in a string, it is reflected by a rigid boundary. Here they are given a rigid boundary. Then the resultant displacement at all time at the boundary it will be equal to. Now only I explained. In the case of a rigid boundary, what is the resultant displacement? Yes, without seeing the option you can answer. The correct answer for this question is 0. Yes, in the case of a rigid boundary, what is the resultant displacement? 0. They are asking about the displacement. They are not asking amplitude. Resultant displacement they are asking. Don't get confused, here they are given amplitude. Next one. Next question. If two harmonic waves of equal amplitude and wavelength are superimposed, then amplitude of the resultant wave it will be depends upon. Two harmonics means when the waves, if they have the same amplitude and also wavelength, everything it will be same. When they will get superimposed, then the amplitude of the resultant wave, what it will depends? It will be depends upon the first option, phase difference of the wave. Second one, frequency of both the waves. Third option, both 1 and 2. Fourth one is none of the above. Phase difference of the wave. Yes. See, when two harmonic waves, when you are having two harmonic waves having equal amplitude and wavelength, when they will get superimposed, then amplitude, resultant amplitude of the wave, it will be definitely it will depend upon the phase difference of the wave. Let us move to the next question. When the two wave pulse overlap with each other, the resultant of the displacement of the resultant wave is the, when two waves pulse overlap each other, pulse or waves, wave pulse like this, okay, you will get the wave pulse now. Two waves pulse overlap each other, the displacement of the resultant wave is the, first one, algebraic sum of the displacement due to each pulse. Second option, vector sum of the displacement due to each pulse. Third one, product of the displacement due to each pulse. None of this. The correct answer is vector sum of the displacement due to each pulse. Always we will consider the vector sum, because vector it will show the direction. No? Algebraic sum it will not show any direction. Vector quantity it will show the direction and magnitude. Don't get confused between these two options. Here they are given algebraic sum. Algebraic sum means only magnitude it will give. For example, 2 plus 3, 5, it will give only magnitude. But when you are consider the vector, it will show even the direction. With magnitude, it will show the direction. That's why the correct option for this question is when two waves pulse overlap each other. When two waves, when they will get overlap, the displacement of the resultant wave is the vector sum of the displacement due to each pulse. Okay, don't get confused. Then next one, which of the following is correct for the constructive interference of the two harmonic waves? Now, just now I explained what is meant by constructive interference. First option, who is there in live, tell me hi, then so I can communicate. Okay, first option, the amplitude of the resultant wave is equal to the sum of the amplitude of individual waves. Here constructive interference they are given. Just now I explained, try to answer. The intensity of the resultant wave is equal to the sum of the intensity of individual waves, both 1 and 2, none of this. The correct answer for this question is the amplitude of the resultant wave is equal to sum of the amplitude of the individual waves. Here when they are given here constructive interference, when two waves, when they will get overlap, their amplitude it will get added up in the case of a constructive interference. In the case of a destructive interference, the amplitude it will get, we will consider the difference of the amplitude, subtraction we will consider, but here in the case of a constructive interference we will consider the sum of the amplitude of the individual wave. Therefore, the correct answer for this question is the amplitude of the resultant wave is equal to the sum of the amplitude of the individual wave. Okay, next question is easy question. Okay, effect of diffraction is greater if wave pass through a gap with width equal to, first option frequency, amplitude, wavelength, wavefront. The correct option is wavelength. Effect of diffraction is greater. Understand the question. Effect of diffraction is greater if wave pass through a gap with width, it will be equal to wavelength. Easy question. Okay. Then visible light has the wavelength of 5 into 10 to the power of minus 7 meter, 6 into 10 to the power of 3 meter, 3 into 10 to the power of 8 meter, 4 into 10 to the power of 4 meter. What is the correct answer? Visible light has the wavelength 5 into 10 to the power of minus 7 meter. Easy question. Easy question. I will move fast. Okay. Next question based on the destructive interference. The path difference is odd number of off wavelength. Second option, whole number of wavelength. Third option, even number of off wavelength. Fourth option, even whole number of wavelength. Odd number of off wavelength. This one you have to remember. In the case of a destructive interference, we will get odd number of off wavelength. Okay, this is the very interesting question you have to remember. Next one, in the case of a constructive interference happens when two waves are out of phase, zero amplitude, in phase, in front, in phase. In the case of a constructive interference, when two waves are in phase means they will get interference in the same phase, in phase or same phase. Okay. Next question, two waves with phase difference 180 degree have the resultant of amplitude. First option 1, same as the single wave. Third option 0, double the single wave. What is the change of the amplitude? 0. Two waves with phase difference 180 degree have resultant wave of amplitude 0. Next question, easy question, that's why I am moving fast. If two waves are in phase and have same amplitude, then resultant wave has two waves are in same phase means constructive interference. Then their resultant amplitude of the resultant wave, half of the amplitude of the single wave, twice the amplitude of a single wave. Third option, same amplitude of a single wave, thrice of amplitude of a single wave. Correct option, twice the amplitude of a single wave. When two waves, when they are, otherwise in the case of an constructive interference, otherwise two waves are in phase, both also same, okay, have the same amplitude, then the resultant wave have the twice the amplitude of a single wave. Next interesting question, for listening radio in cars, external radio aerials are used because radio waves have shorter wavelength, radio waves cannot pass through window, radio waves have longer wavelength, radio waves require a medium to propagate. What is the correct answer? Radio waves have longer wavelength. In the listener radio, for listening radio in car, external radio aerials are used. External aerials we will use. Why we have to use? Because radio waves have longer wavelength. Okay. These are the very easy question. That's why I am going fast. I explained all the concept. That's why. When two waves meet, their displacement. When two waves when they will meet, otherwise when they will get superimposed, then their displacement. First option added up. Second one destruct each other. Third one cancel out. Fourth one subtract down. Easy question. They will get their displacement, they will get added up. Principle of superposition can be applied to EM waves, electromagnetic waves. Second one radio waves, sound waves, almost all of the above. Superposition of waves, all of the above. Whether it is a electromagnetic wave, whether it is a radio wave, sound waves, all the types of waves we will observe the superposition, mixing up of waves, that is common, no? Next question. Coherent source emit wave that have increasing phase difference, constant phase difference, decreasing phase difference, varying phase difference. Constant. Coherent source. Yes, name coherent source. Coherent source, it will produce only one type of one monochromatic waves it will produce. Means monochromatic means the waves it contains only one type of wavelength, otherwise constant wavelength. When wavelength is constant, then normally obviously constant phase difference. Okay, coherent sources, monochromatic, it will produce as a monochromatic light. Monochromatic means the light, it will produce a constant wavelength of light. Okay, next one. Okay, these are the few important questions I discussed today. In the next class, don't miss, I am starting modern physics. Modern physics is important one. Next class I am going to discuss about atoms and atomic models, everything. Modern physics like atoms and atomic models, then Rutherford, Thomson, Dalton, atomic theory, all the types of atomic theory I am going to discuss, and even radioactivity, everything. Modern physics, it contains all the concept. Therefore don't miss my class. In the next class I am going to teach the modern physics, that is the last syllabus in the hstr. Already you know the notification, 58,000 teachers, definitely they will call within 2 or 3 months. I don't know when it will be the notification. Please try to read each and every day. Now you are free, concentrate on your studies. I am here to help you. Definitely if you follow my classes, definitely you can clear the upcoming government exams. Don't waste your time. I am requesting you at least daily read 2-3 hours. That is very necessary for you. Okay, thanks for listening my class. Okay, we will meet in the next class. In the next class I am going to start modern physics. Modern physics is very interesting. Please watch my videos. Okay. Thanks for listening my class.